section, I just selected a very simple problem. Just because the lack of time, just I will very focus on the mesh section and the setting your Fluent file and post-processing. So as you can see in the second slide, it's called or it's known as a shell and tube heat exchanger, and I just simplified that to a rectangle and a circle or the tube, hot tube in the center of the rectangle. So as you can see, the left side is your inlet and the right side is your outlet. It means that the cold water enter your domain on the left side and just pass through your hot tube, and then it exit the domain. So the initial temperature of the tube, hot tube, is the 90 degrees centigrade, and the thickness and diameter of the tube is that the 1 millimeter and 25 millimeter respectively. So the temperature of the cold water is the 20 degrees centigrade with the inlet velocity of the 0.1 meter per second. So just we will monitor the behavior and the trend of the temperature, reduction of the temperature in the 10 seconds. So if you have any question, I think I don't know the rules, but I think you can just interrupt me and ask your question. So just I will apply what I said. Just I double click on the Fluent, or also you can drag the Fluent and just drop that here. So yep, that's it. I can also delete the additional one, this extra one. Yep. For the generating your geometry, you have two options: either design modeler or the Space Game. Space Game is new and it's really user-friendly. And I just select the Space Game, and I think it's a good chance that you can get familiar with the Space Game. Maybe it takes a bit time. But the design modeler also is very popular, so you can use that. And so as you can see, there are two methods that you can enter your geometry. But there are another option is that you can create your geometry with the other CAD software, such as the SolidWorks, such as the Creo, or different things. And then you can import your geometry with the extension file of STEP or STP in the Space Game or model editor. So now you can see that my screen, and now it's the space of the or the environment of the Space Game. So I'm gonna just draw my sketch in the XY plane. So I select this option, the second option, and I just move the grid to the XY plane to look at directly at the XY plane. So I just double click on the Z axis. Okay, and before that, I have to check the units of the dimensions and variable here. So just I think I have to, yep, something goes wrong maybe. Let me just check. Yep, here. So you can go to the unit and check the length. I changed the length to the millimeter. So, and if you remember, the length of the rectangle is the 500 and the width is 160, and the diameter of the tube is 25 millimeter. So let's get back to our Space Game. So just select the rectangle and click here. You can put the length value. It was 500. And if you just press the tab key on your keyboard, so it's locked, and then you can just enter the width value. So it was 160, and then you can press the enter. Now you have your rectangle. If you are interested and you're gonna just center your geometry, you can use this constraint as a dimension. So again, for the double check, yeah, it's a 500 and it's 160. Yep. And just as I mentioned, to put it in the center of the plane, just click here and click in the put a constraint in the X direction, and you can just change it to the half of the length. It was 250. Yep. And just for the aligning that in the Y direction, click here, click on the X axis, and just put the half of the width. It should be 80 millimeter. Now you just center your rectangle in the XY plane. And the second step is that creating a circle in the center, and the diameter is 250. So it's done. It's almost done. Just as a suggestion, as a point, I recommend you just to create a cross point inside the tube, and I will show you in the mesh software that is very helpful to create a structure mesh. Okay, it's done. Just if you hit the end sketch editing button here, now you can see that you have one region here and 4 regions inside the tube. So you can close the space claim. And if you have a look here, you can see that the blue question mark changed to the green tick. The green tick means that it's done and it's ready for going to the next step. So I just open the mesh. For a very simple geometry, you can use this option for the generating mesh. But if your geometry is very complex and you need some advanced methods such as the block, for example, mesh, so you can use for example, as a recommendation, just you find here. Let me just find that. Yep, ISEM. Yeah, here. You can just select the ISEM for generating mesh, but for very complex geometry, not for the simple geometry. So the mesh is ready, and let me just be thinking. Just it takes a bit time. Okay, meantime, it's opening. If you have any question, just please let me know. Okay, it's your mesh. So if you double click on the Z-axis, you can see that this geometry. Okay, so the first step is that you should name your boundary condition and your domain. So I named this one as a fluid domain. Yep, and inside the tube should be named as a tube domain. And based on our problem, is the inlet, is the outlet, and the upper and lower wall are our wall condition. So I just named this one as the inlet, and this one as the outlet, and select this one. I press the control, and I can select the other one, the upper lower one, and name that as a shell walls. Yep. And also I can name these 4 edges or arc as a tube wall. So tube walls. So if you click here, you can see that, okay, you named the fluid domain. We named the tube domain, inlet, outlet, and shell wall and tube wall. I think it's okay for the naming, but for the meshing. So it's my approach. You can just select the other approach. There is no mandatory approach or things. I select this one to select the edge, this option for to select the edge. So here I selected these 4 edges and these 4 arcs. Right click on them and select the, go to the mesh, yep, and go to the insert and select the sizing. Here you have the 8 edges. Yes, it's okay. But instead of element size, I use the number of divisions. It's optional. And I select number of the division as a 10. And I recommend you just instead of using selecting the soft, you can just select the hard one. It's better for the generating mesh. And for the outside of the tube and inside the shell, just you can select the domain, right click, insert, and again sizing. But here instead of the edge size, you have the face size. As you can see, face size, edge size. So for the element size, you can just select your element size can be 5 millimeter, and again change soft to the hard. So as a very rough and very coarse mesh, just we update that, and then I will apply the other option. You can see the difference. Yep, if you click on the mesh, so you can see that it's okay, but you can just have a better, you can create better mesh. But before that, I have to describe some important things about the mesh. As you can see here, and if I just, yep, maybe, yep. We have the structure mesh or generally or unstructured mesh, or sometimes they are called as a mapped or unmapped mesh. So generally, it's better that you use the structure mesh instead of unstructured mesh. But sometimes, like in our geometry, we can't have just generate entire of our domain with the structure mesh because we have a circle inside a rectangle. So it's better that just we have a mix of structure and the unstructured mesh. So let's get back to our mesh. So to have a structure mesh, we have an option here as a face meshing. Wherever that you think that you can have a structure mesh, so you can select this one and you can select your faces. So here I have 4 faces, and here you can just select the method is a equilateral, or for example the triangles. It's better that you use the equilateral. And then also you have another option. If you come here, just you have to run that, update that. Maybe it takes time. It depends on your geometry and the number of the cells. Sometimes it's really, yeah, no, it works because the low number of the cells. So I can just delete this one because it didn't work. And just I select the method. If you select the method, you have to select the geometry. Okay, I select the geometry, and here you have some options. I select the, instead of the equilateral or specifically the triangles, here I selected the multi-zone, as I mentioned, because of you have a circle inside the shell. So you have a structure mesh and an unstructured mesh. So I select the multi-zone as a mix of the equilateral or triangle, and then I select the face meshing and face meshing for inside the tube. So yes, and now I update my mesh. Yes, here as you can see now I have a structure mesh inside the tube and structure mesh here, but they are not a structure mesh, but it's okay. Just you can improve that by the further refinement. For example, you can just decrease the size of element size here. For example, I decrease to the 4, for example, 4 millimeter, and you can see the changes. Yep. And as you can see, based on our problem here, the important area is around the tube. And for example, the shell wall, the upper or the lower wall are not very important in our problem, in our simulation. So to capture all effects around the tube, such as the thermal boundary layer or the hydrodynamic boundary layer based on your CFD and your fluid mechanics knowledge, so you can create some inflation layer through the just selecting the inflation here. So you can just create more dense mesh here. You should know something about the Y+. Hopefully, I think most of you know about the Y+. Y+ is a concept that is just mentioned and emphasized in the turbulent flow. And it is, again, it's just for the capturing the effect of the flow structure and heat transfer, and for example, near the target wall or any surfaces. But the important thing is after that you create a mesh is that evaluating your mesh. How you can evaluating your mesh? There are a couple of factors that you have to consider them. For example, you can just, if you go to the select the mesh and in the display style, so you can have a lot of options here to evaluate your your mesh. But let me just give you some points. The mesh quality is very important, guys. So for the mesh quality, always it should be greater than 50% or 0.5. So if you, for example, select the mesh quality here, so here it should be element quality instead of the mesh quality. So you can see that my mesh is over the 0.5. So it means that my mesh is good in terms of the mesh quality. And the other option, for example, is that the skewness. Skewness is very, very important because it can just lead to your the divergence in your solution in Fluent. So skewness always should be less than 0.33. And skewness is defined as you can see here, the difference between the shape of your cell compared to the shape of a equilateral cell with the same volume. Another factor is the aspect ratio. The aspect ratio always gives you the stretchiness of your cell. So it depends on the different problems and the different physics which governs on your problem. For example, generally you can consider this factor less than 10. If it's less than 10, so you can just consider that as a good condition. It's in a good condition. And the other one is that the orthogonality. Orthogonality also is available in your Fluent, and you can check that the orthogonality. So let's just have a look to different options. For example, the aspect ratio. So you can see that, yeah, the aspect ratio should be less than, for example, 10. For me is the 1.7. So it means that it's okay. And also I can check that skewness here. Yeah, skewness, as you can see. But my the greatest one, the greatest value is that the 0.4. So it means that if I just decrease the size of the element, I also can improve the mesh. So after that, you make sure that, okay, your generated mesh sounds good, it's okay, and it's ready for the importing in the Fluent. So just you can close your mesh. And you can open your Fluent file. As you can see, now I got a green tick here and I'm ready just to open the setup file. Setup file, just the geometry and mesh. Keep in mind that there are two additional software that they have been added to the Fluent, but your Fluent can start from the number 4 as a setup file. Here you have a couple of, you can see a couple of options. It's suggested that you use the, always you tick the double precision. And also here you can just actually import the number of core. For example, I enter 3. It depends on your system configuration. You can check your system configuration. And if you have, for example, 7 or 8 cores, so you can just import 70 or 80% of the number of cores here. So I just click on the start. And also there are the other option here. For example, you can select, you can just, maybe you can, based on your problem, maybe you can change the work directory, or also there are the other options such as the environment and something like this. So I hit the start. Okay, meantime it's opening. Let me just I quickly review about the mesh independency or mesh independence study. So after that, you make sure that, okay, your mesh, your generated mesh is okay. Just you import it in your Fluent, and you have to consider important parameter in your simulation, monitor that, and you have to just check for the other mesh configurations, for example, for further refinement, because your solution should be independent on the size of the, for example, and the number of the cells. So it's very important. Always you have to check the mesh independency in your study. So always you have to do that as a, for example, engineer or designer that do the CFD study or any numerical methods. So as you can see, there are a lot of options here, but just you should know some relevant options, because, for example, there are the other options such as the user defined that is not necessary today, or the other option that I give you very brief information. So if you double click on the general, you can see this task package here. You can just scale your geometry. I just again change the length unit to the millimeter. That's it. And also if you are, because the temperature, yep, is given in the centigrade, so you can just change the temperature. You can find your variable. For example, my desired variable here that I'm looking for, that is the temperature. And instead of the Kelvin, I select the centigrade. That's it. And then hit the close. That's it. And also there are some options such as the solver. The solver generally is based on two approaches, the pressure based or the density based. And there are a lot of material and info and resources. You can just read them on the internet, but as a brief note, I can just say that the pressure base is proper for the incompressible flow, while that the density base is very suitable for the compressible flows. The other option is the time. Time can be steady or the transient. If you don't know the difference between them, Transient means that it's not the transient that you have in the fluid mechanic as for example the laminar transition and the turbulence. No, it's the transient and it means that if your problem is dependent on time and it varies with time, it means that it's the transient. So you have to select the transient, and based on our problem we have to check for example the temperature of the tube, the hot tube, after 10 seconds. It means that our problem is dependent on the time. So I just select the transient. The gravity, yes, I apply the number of the gravity here as then minus 9.81 in the y direction. Actually, in the minus means that in the opposite side of the y direction. Also, there are some options here. You can check your case, and also you can check the quality of your mesh here. Also, in the domain tab, you can just click here on the info and see the number of the cells. Yep, here the number of the cells is over the 6,000. So it's okay, and just we can jump to the next step. In the model is very important step in setting up your Fluent file. Your solver is single phase, so it means that you should leave the multi-phase as a off. It's okay, but you need the energy because, as you know, the CFD problem is based on the continuity conservation equation and the momentum equation. And if you wanna consider the energy and temperature, you have to active that. And to active that, just double click on the energy and just active and put a tick here, and okay, that's it. And the next one is the viscose. It depends on your problem. Sometimes your problem is viscid or inviscid. So if it's in viscid, just you have to select the inviscid. But if it's inviscid, it means that there are two states. The first one is the laminar, and the other one is that turbulent. So if your problem is the laminar, you can select that laminar, or maybe you can just select the turbulent model. And there are a lot of options here. So if you have, if you need any information, just anytime you can just click the help, and it's very helpful theory guide and the user guide for the Fluent, and they are very understandable, it's readable, so you can just find a lot of valuable information and data. So I select the K epsilon here as a K epsilon standard because there are the other types such as the renormalized group as the RNG or the realizable. Let me just show you some slide regarding the different, here, the difference between the RANS turbulence model. Definitely you should know the RANS. It means that Reynolds average Navier-Stokes models on equation, and each of them has some strengths and the weaknesses. So you have to consider and select them based on your problem and based on the previous study, because in the literature review you should know that, okay, for example, the RNG is very suitable. RNG K epsilon is more suitable for example, impeachment jet. So I select the RNG, and then you have to test that. If you get the valid results and expected results, so it's okay. Just you can stick to that and just run your simulation with the, for example, RNG K epsilon. So it's your responsibility, it's your task to select and choose the, for example, your model, your turbulent model. Here, just as a practice, and I select the, for example, the K epsilon standard, and the other one is the near wall treatment. Near wall treatment again is relevant and it's related to the Y plus. And for example, for the standard K epsilon, the Y plus for the selecting the standard wall function, the Y plus should be between around the 30. But for example, for the selecting the enhanced wall treatment, the y plus near the target surface or near the wall should be less than 1. So you should just consider this important factor in generating mesh. And also there are the other coefficients here. So you can change them if you have any evidence, if you have any previous study that recommends you, suggests you, propose that. For example, you can change the CMU or the other constant. Otherwise, like this situation, I'll consider them as a default values. And radiation, no, there is no radiation, it's negligible. So just I skip this one. I skip the heat exchanger. I skip the species. It's generally for the other problems. Discrete phase model is like it's a kind of a multi-phase model. And I also published 3 or 4 papers with the discrete phase model, but it's not suitable for this problem. So just I jump to the next one because I don't need to select the other option in the model sections, and I go to the material. Here just I have, as you can see, I have steel as a solid one, and the important thing is that the water. So I have to check that the water is selected or not. Definitely by default, no, just we have air. So you can double click on the fluid. Yeah, it's opening. So in the fluid, just we have air and we have to add the water. There is a very good database in your Fluent. So click on the Fluent database and find the water. The water is this one, and just copy, close. That's it, and just create and change. So now we have air, we have the water liquid. Also for the solid one, we have the aluminum. You can change that, or you can add the, for example, steel, or you can just kind of keep the aluminum again. Depends on your problem. Here, instead of the material type, it's a solid, and I selected steel, copy, and create, change and create. That's it, it's done. So I open the other one, other section as a cell zone. If you remember, I defined 2 domains, as a shell domain and as a tube domain. So I expect that just I have the fluid domain. So yep, it's, as you can see, yeah, but in here you can select that, for example, in your domain, you have water or air. Definitely we have water in both regions. So I apply that. And here is a tube domain. Tube domain, inside the tube domain, we have the hot water, and it's running, and Fluent automatically recognize that it's solid. No, it's not solid. And just to change that, you can right click here on the type, yep, here, and as a fluid. And instead of air, select the water. That's it. Now we just define our cell zone condition, and the other one is a boundary condition. And also these options are available. You can just select them here. For example, the boundary condition, your inlet is this side, the blue arrows. So click on the edit. It's a velocity inlet, so automatically correctly is recognized. It's okay. And the velocity inlet was 0.1 based on the problem definition. And just I consider the default values for the intensity and velocity ratio. And the inlet temperature for the cold water is 20. So that's it. The outlet is the pressure outlet. You can just open that. Okay, yep. We don't need to change anything here. The shell domain, the vault, that's it. And it means that we've done the boundary condition. And the next one is the method, as you can see here, or also you can just open here the method. There are different methods for the coupling or coupling the pressure or the velocity. I select the simple, and there are the other options. It's available in the version of the 2021 R2, and I select the momentum base here. There are different options. For example, for the turbulent kinetic energy, you can select the first or the second order. Definitely, you should know the difference between the first order and the second order. It shows the actually the accuracy. And if you select the second order, it means that you increase the accuracy of your solution. But sometimes, because limitation in the computational time, in the computational facility, and also it depends on the accuracy that you expected in for the solution, you can select the first order or second order. So just I change all of them to the second order to increase the accuracy. And also here the transient formulation can change to the first or second order. I consider the first order. And the next one is the control. Here is on the relaxation factor. Maybe you ask me what is on the relaxation. I can say that on the relaxation is useful to moderate prediction of, for example, your variables such as the velocity, such as the pressure or temperature in the next iteration. Sometimes for the converging, you have some problems, some serious problems, and you have to moderate the your simulation and the prediction. So to do the under relaxation, you can just control that. It's very useful. The formula is very simple. If you just again click here on this question mark, you can see that the formula for the under relaxation factor. And that's it. And the other item is the selecting and defining your residual. So mostly people use the 10-6 or 10-5 for the residual. The residual means that when your residual drop or fall or less than the 10-6, it means that your solution is converged. So that's it. And also now you have to initialize your method from your numerical method that you maybe you have taken as a unit in the university, or with the other names such as the CFD or the numerical approach. It's not important the name, but the concept is that always you have some boundary condition and you have some initial condition for starting the simulation. So for the initial condition, so you can initialize your problem in Fluent. You have two approaches, the hybrid and the standard. I recommend you use the hybrid because the hybrid consider the all boundary condition and all, for example, initial values. So it's better that you use this one and press the initialize. It's thinking, maybe it takes a bit time and we have to be patient. Again, if you have any question, you can ask me. Please let me know if you have any questions so far. Yep, again, I press that. Yep,
no, sir, it's clear.
Oh, okay, thank you. Thank you for update. Actually, today I select a very simple problem but along with I just focus on some important points, especially in the mesh and also for the setuping of your Fluent file, especially for the post-processing. I know we have a lack of time, but after that, I will show you how you can have some post-processing on your results. So as you can see, the residual in the initialize reached the 10 minus 12 is very good. And the next one that we missed that is that the temperature inside the tube. So I just simulate that we have water that enter from the left to the right side. But I have a hot water inside the tube. How can I apply that? There is an option, it's patching. So click the patch, click on the temperature and the fluid domain. And as you remember, the temperature is the 90 degrees centigrade. So I just put the 90. That's it. And temperature for the fluid domain means that the shell domain inside the shell. So it's the 20, if I remember correctly. Yep, 20. So I patch that, and that's it. If you are interested in just in monitoring of your temperature, so you can, inside the tube, just you can click on the report definition, new, and for example, select the volume report, volume average, and what is the field variable that you are looking for, temperature, where you can select the cell zone that is a tube zone. So that's it. And yes, I create a file and create a plot. When you tick a report plot, it means that you have a individual window that pop out and you can see the, for example, trend of the temperature. That's it. The other option that I can, maybe just also there are some options such as creating some animation, but I think just because the lack of time, just we can skip that. But if you are interested, yeah, you can just click on the
Can we use
calculation.
steam in the tube? Can we use steam in the tube?
Sorry.
Sir, can we use steam in the tube? Steam in the tube and outside shell water.
Yeah. Inside the tube, doctor, actually, we can consider the different things. But here, just because the maybe computational, some limitation in computational facility and time, just I consider a stagnant water inside the tube. Yeah, definitely we can consider for example, the multi-phase. But it's better that if you use the multi-phase inside the tube, you consider your geometry instead of the two-dimensional into the three-dimensional. But definitely, yes, you can just consider the multi-phase inside the tube as a stream, or that's it.
Then we have to make the multi-phase on.
Yep, exactly. Yeah. I'm interested in the multi-phase, and I work with all of multi-phase model, such as the VOF or the mixture model or the Eulerian. Eulerian is expensive, but the other ones, such as the VOF, I think is very cost effective, and you can use that for the steam. Yep.
Okay. Thank you.
No worries. Actually, that's it, I think. Yep. The next one and the last.
Dear Jawad,
Yeah. Hi, Shahid. How are you?
yeah, you can take some more time if you want.
Okay. Yeah. I'm okay. Yeah. Thank you. Thank you. And the next one is, guys, is the solution. And the solution, as you remember, I just selected in the general, I selected the transient instead of the steady. But again, if you have any question about the transient and steady, please let me know. I can just elaborate on that. But yes, I selected the transient and time step. it needs some study because your solution should be again independent on the time step. Like that, I said that your solution should independent on the mesh size. So, but here again, just because of time, I selected the 0.1. Just you can change the different time steps. I mean that when you change your time step after the 10 second, you should not see any difference between your solution. If you see a difference, definitely you have to just decrease the size of your time step. You should do that again and again till you reach a steady condition. A steady condition, or it's better that I use the, your result should be similar, should be the same. It means that your solution is dependent on time. Yep. And the number of the cell, if you remember, we get asked for the 10 second. 10 second, it means that 10 second, we have to consider 100 time step. 100 time step multiplied the 0.1 means that 10 second. Yep, and here you have some other option. You can, if you have enough space to store your file, yeah, you can select that. For example, every time step, every time you can, it's the frequency of your autosave. For example, you can define here the 1, 2, or every 5, for example, time step, you can store your data file. It's important if you are interested in, for example, generating some animation file. Yep, that's it. Now just I save my project. One option that I miss, and I will point it out now after that saving. In transient problems, the other important things is that, let me just show you. Yes. If you go to if you click on the run calculation, it's thinking maybe it takes time. Longer time, maybe a bit. Yep. I think, no, it's ready. Yep, run calculation. Here you can see that, okay, you can see 100 number of the time step and the time step size, but this one is very important. Here you can mention the maximum iteration in each time step. So for example, I enter this, for example, or maybe you can consider 100 and then press the calculate. Yeah, and now you can see that the residual window will pop up. Yeah, start. It's our first time step, and as you can see, the maximum number of iteration was 50. Yep. And as you can see here, the initial temperature of the tube was 90, and you can see a decreasing trend. Why? Because you have the cold water which surrounds the tube, and it means that your hot tube, just the temperature of your hot tube will decrease consistently, as you can see here. So it means that in the time step or in the flow time of the point 2, your temperature inside the tube is around the 89.4, or it means that the 0.6 temperature reduction. So yep, just we can wait for the final result, or maybe we can stop the simulation. You have two options here: stop at the end of iteration. It means that as soon as possible the iteration done, so it will be stopped. And the other one is that stop at the end of the time step. I recommend you that use this one, because you can just keep your simulation and your data for each time step. So I select this one. And as you can see, it's my residual. If I created a more precise mesh, definitely I couldn't see for example, the residual should be less than 10 minus 5 or minus 6. So because of that, I emphasize that the grid size is very important. And as you can see here, it's a temperature trend of inside the tube. It's a decreasing trend. And for the further post-processing, because as you can see here, we have a 3 main step in CFD problem. The first step is the pre-processing, then processing, and the last one is the post-processing. Modeling, or for example, applying some initial condition, boundary condition, all of them, they are categorized in the pre-processing. And the step that you can see that it was solving and your problem and the simulation was processing, that I stopped our simulation because of the time. And now we're gonna go through the post-processing steps. So for example, here you have the graphics, and if you double click on the contour, you can see that the pressure contour. And just for the 2D, it's very important point, guys, just keep it in mind that for the 2D problem, it doesn't need to consider selecting the surfaces. So just if you selected them, so you can see that something like this, but it doesn't need, you can just deselect them just in 2D problems. So you can see that some lower pressure drop, some lower pressure up and down of the tube that is expected. But we can't judge our results because we have to wait for a while, at least for the 10 seconds, and then we can just justify our results. Just I show you, and I don't want to justify any results or, for example, any separation, because our simulation should be and reach to the steady or quasi-steady condition. And the velocity, as you can see here, yeah, it's expected that we have the maximum velocity here. Or temperature, as you can see, the cold water around the hot tube. So you can zoom in and you can see that it starts to being cooled. And the other option that if you are interested to know, the other one is the vector. And also you can just selecting, for example, instead of the 3D, you can select in 2D and click here. You can see that the flow vectors is very important. Sometimes some students, some researchers just rely on the residuals. It's one step, but it's not the whole thing. The important thing is that after you converging does not mean that your solution is okay. it's a necessary part, but it's not the all things. You have to check, for example, your vector. You have to check your, for example, velocity contour if they are expected and desirable. So yeah, you can just say that my solution converge. That's it. Also, you can here actually draw and show the streamline if you are interested. I skipped this one. Also, you can have some reports here. If, for example, if you go to the, for example, the volume integral and select the temperature, for example, volume average, you can see that the temperature of the hot tube actually decreases and decrease to the 88.2 after a while, after just less than 1 second. If you are interested in generating more professional features, so you can just close again. Yep, you can close your solution part and you can open the results section. So maybe I can open that. I don't know, maybe. Yep. Now, the professional part of the post-processing is the results, or it's called as a CFD post. So I open that. Yep, it's the CFD post. As you can see, CFD post. If you double click on the Z, it's your geometry. So you can, for example, create a plane. Yep. In the XY, yep, it's okay. So you can just deselect that and you can go to the graphics and the contours. All domain, yes. The location, the plane one that just we created that. And for example, the velocity here, global or the local, and here you can just define the accuracy of your mesh or the contour level. I selected the 300. Yeah, as you can see, it's very professional, and also you can create, for example, vector here or the streamline. If you use the discrete phase model, you can use this option to just monitor and just to see the particles. And also you can create some lines and you can create some graphs if you are interested in generating some graphs or XY, for example, a line graph. And after that, for the exporting, you can go here and select the export, or maybe you can save the picture. Yep, you have different options. If you have a software that you can open the this one, let me just, yeah. If you can open this option, so I recommend you use to this one, or maybe some vector if you don't have the proper software. So you can select the, for example, the JPEG or the PNG.